Now let us see how actually this transistor can be used as a switch. We have a potential of around 5 volts given to this circuit. We have a 10k resistor which will be connected through a switch to the base of the transistor. This 10k will basically limit the current that is coming towards the base, as the base is very sensitive and may get damaged if it is given directly the 5 volt supply. And this is the collector through which the supply will come, and the emitter is completes the circuitry. So what we expect when this switch is closed, this circuit will be made and the base will get the supply, which will in turn turn on the transistor, and thus this circuit will get completed. Then the load, or if a load is connected over here, it will get the supply, and if a load is connected over here, the supply will be cut off, as it will be acting as a short circuit and the supply will be 0 volt over here. So now let us close this switch. As expected, the current started flowing through the transistor, and we got the supply over here coming through the collector. So in this way, this transistor works as a switch. Now this switch can be replaced with a digital switch, that is with the help of a microcontroller, and can be switched using some logic that is programmed in the microcontroller. So this was how a transistor works as a switch. Now let us move on to the next section. So this was the transistor section. Now let us move on to the next section, that is relay. Now relay are electromagnetic devices which can work like a switch for it can work like a single pole double throw switch according to the supply given to its coil. So suppose this is the coil through which the supply will be given. This is a common, that means the signal that is to be passed, and these are the two terminals named as NC and NO, that is normally closed and normally open. As the name indicates, normally closed is the terminal to which the common terminal is connected whenever there is no supply given at the coil. So if a signal is given to the common at this moment when the coil is not energized, the signal passes through the normally closed terminal. Similarly, normally open is the other terminal of the relay, which gets connected to the common terminal whenever there is a supply given at the coils, between the coils. So if this coil is energized, then at this moment, due to the electromagnetic attraction, this terminal gets connected with this terminal. That means the normally closed now gets open, and normally open gets closed with the common terminal. How this happens actually is that this coil is actually an electromagnetic. Whenever rated voltage, for example this coil is rated for 12 volt, if we give a 12 volt across these terminals, it can be either way, either this way or from this way, then it gets energized and it gets magnetic attraction. The switching material is also magnetic material, and it gets attracted towards other magnet. So when this coil is energized, it gets magnetic attraction, and this terminal now loses contact with this terminal and goes towards this terminal and gets attached to the normally open. So in this way, a common relay, a 5-terminal relay works. Now let us see a simulation of how this actually works. So what we have over here is a setup of simulation of a 5-volt relay. This is a 5-volt relay, as the coil is rated for 5 volt, and now typically it's in on condition as the supply is going through this coil and through the 100 ohm resistor. This 100 ohm resistor is connected because of the design considerations of the coil. As the coil is having some internal resistance, there should be a series resistance connected with it so that the current gets limited. Now as the power supply is on, the relay is on, that means the coil is energized, that means there is an electromagnetic attraction for the switch, and thus the switch is towards the normally open condition, and that is why the 100 ohm resistance is getting the supply from the 5 volt power supply, and the circuit gets completed through the ground. Now suppose we want this to happen through the other 100 ohm resistor that is connected over here. This can be done by simply switching this voltage off. Now what we see that the relay has been switched and it has moved towards a normally closed condition. This is a normally closed condition in which the supply is now moving through this resistor and to the ground. So now let us again put the relay on by setting the voltage. Now again, as the coil has been energized, the supply is going through this resistor, and this is because of the electromagnetic attraction forces that is attracting the switch towards the normally open condition. So this was the simulation of a relay. Now let us move to the next section. Now let us move to our next section, that are the motors. Now depending upon our use, we can use different kind of motors. Basically there can be used three type of motors. One is the DC motor, the other being the servo motor, and the other being the stepper motor. First we'll talk about the DC motor. The DC motor can be connected either ways. That means the polarity can be from positive negative over here, or from positive negative from here to here. That means this motor can run in both the directions. The rating of the motor determines what voltage should be connected across it. For example, if this motor is a 12 volt motor, so the supply should be 12 volt, and if the supply is like given less than 12 volt, the RPM will be less than the rated RPM given at the rated voltage for the DC motor. Now let us move on to the servo motor. The servo motor is a bit more complicated than a normal DC motor, as it works on the PWM principle. Here we have only 3 terminals for a servo motor. One goes through a resistor to the pin which gives the signals for it to be positioned. The second one being the supply voltage. Usually the servo motors work on 5 to 6 volt range, and a third one is a ground. Now depending upon what information is given by the microcontroller, this servo gets its position. So servo motor are used wherever the position or the accuracy of the position is more important for the user. For example, if someone wants to turn the motor for only 30 degrees, so this servo can be given appropriate information by the microcontroller, and the servo turns for only 30 degree and remains over there, which was not there present in the DC motor, as we didn't knew how much it will traverse for in a given amount of time. Now moving on to the stepper motor. The stepper motor is slightly different from servo motor, but again the usage can be similar. That means for knowing the appropriate position at a given moment of time, Actually, the stepper motor, as the name indicates, it moves in steps, and the number of steps is actually defined by the gears it has on the top of it, mounted on the top of it. Now the stepper we have here is a 6-terminal stepper motor, from which 2 are actually connected to supply. The black one and the white one are connected to the supply, and the red, the yellow, the blue and the orange are the data pins, which are from which the motor will get information from the microcontroller to be positioned accordingly. How this works is that when a microcontroller gives a high at a red, the stator of the rotor aligns itself with this pole connected to the red one. Similarly, the next one, that is a yellow, when this one is turned high, now the stator aligns itself with the yellow, and similar goes with the blue and the orange, and then again with the red, and this cycle continues in this way. So in this way, in 4 steps, the rotor rotates according to the steps given by the microcontroller or any controlling unit. So in this way, a stepper motor can be controlled for a given position. So in this way, we can use 3 different types of motor in our projects according to our usage.